Assalamualaikum, my name is Muhammad Zuelmi Bezana Fitri. My metric card is 192210 and this is the subject digital signal processing. So there are two parts of the task given in this assignment. The first part is how we can use the sine wave with frequency of 1 Hz to compose square, triangle and sawtooth wave. How we are going to do this by using a Python. Now the way we use Python to plot the square, triangle and the sawtooth wave is by using, firstly we start by importing the library for this of this Python language. The first one is we import the matplotlib pipeline as the library. Why is the use of this library? So the use of this library is for us to draw to present the wave that we have just made in as an image for us to view the square wave, sine wave. If not, we cannot view it, but we still have the program that running that can plot it at the back of the programs. Next we have the NumPy library. So the use of this NumPy library is that it can be used it is used for the dimensional arrays and matrices along with large collection of high-level mathematical functions to operate on these arrays. So the reason we use NumPy is for us to do the calculation for the wave, for the square wave, for the triangle wave and for the sawtooth wave, for it to operate. Therefore the use of the NumPy is for the as you can see here, the use of the NumPy is being used for the mathematical formula that exists for the wave that had to exist for the wave to be plotted. Now so this is the part that we use for the wave. Now we move on to the plot figure. Now as you can see here, we use the plot figure. This is based on the library of the matplotlib library to generate the wave that had been produced at the program. So let me show you how it works. That's it, and there we go. We got a square wave, a triangle wave and a sawtooth wave. Both of these libraries are combined for it to operate, calculate and generate the wave that we can see right here in the screen. Next we move on to the task number 2. Task number 2 is about us to make a sound in a file, and then using the programs. For me, I use Spider for the program to upload it, to read the file of to read the audio file and represent it in the wave that we can view. It's like yeah, that's how we are going to do. So for us to do that, firstly we need to record. Of course we need to record our our audio. Then the next thing is we need to process the audio in order for the program itself to read the audio file. How we do it? Okay, first we have three libraries here, and the two libraries that I have mentioned, as you can see here, there are two libraries that I have mentioned for the Task1, which is the matplot library, matplotlib.pyplot library, and the numpy library. Both of these are used to represent the wave that are going to be viewed later on, and to use the calculation for the audio file. So the third one and the new the new library that we use is the wave library. Why we use the wave library? The wave library is used for us to read the audio file that we have created for the program to be understand what it need to do to the file. Okay, for example, on this line here, we program the file, which this is a command wave.open. This is the name of the file, and this is we put R in the calibrators. Why we put R? R is used to represent that we want the program to read the audio file that we had created. If we put it in W, it will become write. We are writing the file, and if we put R plus, then it's going to be the reading and writing of the file. So for this specific task, we are required to read the audio file that we had been created. Therefore, it is better for us to only use R read the file that had been created. Next, and then we use the command to represent. After we read it, we use the command to present the audio in the waveform, and finally don't forget to close our file. Since we open it, we need to close it, or if not, if going to read the entire file as long as it had, and which will make our program problematic. So let me show you the result of this. And there we go, we got our wave. Okay, that's all from me. Thank you very much.